Can your graph drive a defensible decision by Friday? Imagine this scene for a moment. It is Monday morning in a hospital operations room. 12 ambulances are incoming. Only 4 beds are available. 2 nurses called in sick 15 minutes ago. And everyone in the room is looking at one screen, hoping the system will guide the next decision without guesswork. On that screen sits a beautiful knowledge graph with clean classes, elegant relations, and ontology work that looks almost perfect from a modeling point of view. And then the operations lead asks one simple question that changes the mood instantly. Who gets prioritized right now and why? And suddenly, even with all that semantic beauty, there is silence. Not because the graph is wrong, but because the graph is not yet ready to carry live decisions in real time, under pressure, with consequences attached. If you work in RDF, you probably know this feeling, because we can spend weeks building meaning, consistency, and structure, and then real life arrives asking for action in seconds, not in workshop timelines. And right now, this gap is even bigger because every executive is saying AI. Every board is saying knowledge graph. Many teams still underinvest in knowledge graph expertise, and even when they hire, they often do not define clear KPIs for decision quality, response time, ownership, and audit trails. That is the failure mode. Beautiful model, no operational answer. So this video is not about prettier ontologies, and it is not another abstract talk about potential. It is about one hard test that decides whether your graph is infrastructure or just a promise. Can your graph drive a defensible decision by Friday? One company turned that pain into market power. Let's zoom out and use Palantir as a benchmark, not as a hero story and not as a villain story, but as a clear example of what happens when a company turns data work into decision work. Their story starts in 2003, and from the early years, the focus was not nice dashboards for quarterly meetings, but difficult environments where decisions cannot wait and where data is fragmented, high stakes, and politically sensitive. And whatever opinion someone has about Palantir, the point that matters here is that they built around operational loops, not static reporting. In simple terms, they did not package data integration as a better view of the past. They packaged it as a way to make a traceable decision in the present, because a recurring pattern in major deployments is ingest broken data from many systems, align entities and objects, apply permissions and policies, trigger action, and write outcomes back so the next decision is not blind. And in the AI rush, that difference became expensive because the market now rewards teams that can connect data to action with accountability, not just teams that can present a cleaner data model. That is the shift RDF teams need if we want to move beyond pilots. We are already strong in modeling truth, but now we must model action, ownership, and consequence in ways that business leaders trust under pressure. So, what did the market reward exactly? If we follow the timeline, the response was not random. Public listing in 2020, positive GAAP profitability in late 2022, S&P 500 entry in 2024, and then major momentum in 2025, with one repeated signal being growing belief in a decision engine story alongside broader AI-driven momentum. A major part of that 2024 to 25 momentum was also AIP and the LLM wave. But the nuance that matters is this. Palantir's moat was not just using LLMs. It was grounding behavior in enterprise context, objects, relationships, permissions, and workflows, so outputs could be operational instead of just fluent. Underneath headlines and valuation debates, the behavior remained simple and consistent. Data enters, identities align, a decision is produced, action is executed, outcomes are captured, and the next cycle starts with better context than before, which means the system can become more useful over time if feedback quality is maintained. This matters for RDF practitioners because the lesson is not copy Palantir's brand and not copy a closed stack, but understand the loop they made hard to ignore. Since many RDF programs still stop one step too early, at semantic correctness, while operational value appears one step later, when a graph can carry decisions that are fast, explainable, reviewable, and grounded in real policy and context. Back to the operations room. The team is deciding whether to reroute an ambulance and delay a non-critical transfer. And in many organizations, that decision still lives in chat threads, verbal memory, and disconnected spreadsheets that nobody can replay cleanly 2 months later. In operational semantics, that is not acceptable because a decision must become a first-class data object with explicit fields and relationships, meaning you model the decision itself, the actor who approved it, the timestamp, the evidence used, the policy basis, and the resulting outcome, so later you can query not just what happened, but why it happened, who approved it, and what changed next. This is where RDF can be extremely powerful in practical terms, because it naturally represents context and relationships, supports provenance-style tracking, and lets you ask meaningful questions across time instead of digging through logs and hoping people remember details under pressure. So the mindset shift is subtle but decisive. The key question is no longer, what data do we have, but what action did we take based on what evidence, under which policy, and what happened after that. But even that is not enough if invalid actions can still slip through. That is where the gate comes in. This is where many demos look convincing and then fail in production, because open-world reasoning is excellent for discovery, while operational flows also need explicit gate checks that can reject invalid actions before damage happens. In our hospital example, imagine a junior role trying to approve a high-risk reroute without required evidence and without correct permission. In a live environment, the system must stop that action immediately and consistently, without relying on manual vigilance or fragile query hacks. That is SHACL territory. You define role constraints, transition constraints, and evidence requirements in a way that is explicit and testable, so the system can reject non-conformant writes and accept conformant ones. At the same time, in high-velocity systems, full SHACL validation on every write can become a bottleneck, so teams usually design a trade-off: critical checks in flight on the hot path and deeper validation at rest asynchronously in the background. Inference helps you discover possible knowledge. SHACL defines conformance rules for state transitions, and your write pipeline enforces pass/fail behavior with the write in flight versus at rest balance. That separation is not a nice to have. It is a trust boundary, and even with perfect gates, you still lose if speed fails. Now let's talk speed, because business trust has a clock attached to it, and when response time is slow, confidence drops even if the ontology is excellent. Decision time systems often fail when every urgent query triggers deep joins across cold triples, because by the time the answer arrives, the operational moment has passed, and then teams quietly return to spreadsheets or manual shortcuts, which is exactly what we are trying to prevent. So yes, keep semantic richness in the core graph. Absolutely, but for live decision paths, create hot path views, materialized projections, and pre-computed state snapshots that provide fast reads when action is needed now, not later. This is not anti-semantic engineering. It is semantic engineering that accepts runtime reality, because in production, speed is not a cosmetic feature. Speed is part of correctness and part of trust. Another place graph programs break is versioning, and they rarely break loudly at first. They break quietly over months until nobody can replay history with confidence. A predicate gets renamed without a migration plan. A shape changes without compatibility checks. Old records become hard to interpret, and suddenly yesterday's decision context cannot be reconstructed defensibly, which means governance has already failed even if the UI still looks fine. Operational teams treat ontology as a version contract, with staged evolution, scripted migrations, and replay tests across historical records, so policy can change without erasing the meaning of prior actions. If we cannot replay yesterday's decision chain reliably, then we cannot claim control over tomorrow's AI-assisted decisions, no matter how modern the architecture diagram looks. And this is exactly why ethics cannot stay at the slide level. Once systems affect policing, immigration, healthcare, defense, or public services, people ask hard questions, and those questions are valid. Palantir's growth came with strong public criticism and concern, especially around large-scale monitoring capabilities and immigration-related contracts. And regardless of where anyone stands politically, the technical lesson for RDF teams is clear. If accountability is not encoded in the data model, then accountability is mostly a story, not a system. This is not endorsement and not condemnation. It is an implementation lesson. So ethics has to become structure you can query. Who accessed what? Who approved what? Which policy was used? What evidence supported the action? And what changed afterward, without depending on private memory or selective reporting. The practical objective for RDF teams is therefore not to copy Palantir branding or messaging, but to build transparent, testable decision architecture where policy, evidence, and outcomes are linked and reviewable at any time. So how do you start without boiling the ocean? If you want Palantir-like operational behavior while staying in an open standards world, start small and deliberate, because one working slice beats 10 broad promises. Pick one painful loop: hospital triage, fraud holds, claims escalation, supply rerouting. Then model the decision object explicitly in RDF with actor, evidence, policy, outcome, and time. Enforce state transitions with SHACL gates so invalid actions are rejected on write. Serve live operations through fast hot path views, while the core graph keeps full semantic context. And treat ontology evolution as a managed contract with versioning and migration pipelines that preserve replayability. You do not need a giant platform first to prove value. You need one loop that works under pressure, produces measurable outcomes, and survives audit questions 6 months later, because that is the same test again. Can it decide by Friday? Can it be defended 6 months later? Return to that first moment in the operations room when someone asks, who gets prioritized right now and why? And imagine being able to answer in seconds with a full chain. Who was eligible? Which rule passed? What evidence supported the choice? Who approved it? And what happened next? Then imagine coming back 6 months later and replaying that same chain without guesswork, without missing context, and without post hoc excuses. That is the real line between a graph as a promise and a graph as infrastructure. And that is the final test worth keeping. Can your ontology drive a defensible decision by Friday? And can you still prove why months later? If this is the kind of practical RDF content you want, like the video, subscribe, and share it with one person who is still stuck in pilot mode.